This recording will cover Chapter 11 from your textbook, and I've also included a bunch of other slides from a presentation that I've done over the last few years about teaching math to individuals with learning disabilities, so I wanted to include some of those slides as well. So this one is a little longer than most of the other chapters, but I have some jokes for y'all. Get ready. They're good, hilarious math jokes. How come 4 never asked out 5? Because it was 2 squared. Get it? 4, 2, TWO squared. Come on, that's funny. But there's some jokes in here that you can share with some of your students because maybe it might make some of them a little more interested in math. I like math. Oh, I forgot to tell you, yeah, chapter 11 is assessing teaching math. So I do have some math jokes, trying to get your students interested. My dissertation was about math, so I have all sorts of jokes and fun things to share with y'all in this one. So some factors influencing math success. Well, guess what? Part of it is the teacher's lack of knowledge and understanding of math. Or if you hate math and you let your students know how awful math is, that is what they are going to think, right? So we need to have teachers who know and understand math and who also like it or at least can pretend that you like it while you're teaching it. Typically, there's poor curriculum and materials, right? A lot of schools spend a lot more money on ELA materials than math. So poor math always is, kind of pushed to the side, unfortunately. And then there are all these other characteristics and factors that might influence math success or lack of it. Math disabilities, right? Learning disabilities. So for some of your students, they're really going to struggle with math. So you want to think about how to teach a full range of math skills. Basic facts, operations, algebra, all the way up to fractions, math applications, stuff like that. Math language and vocabulary. Thinking about chapter 10 when we were talking about content area learning, how can you incorporate more math vocabulary? And you also want to think about, kind of in the day-to-day instruction. And also thinking about using clear, concise math language when you're teaching and really take the time to explain math terms. Again, math terms are unfamiliar to students, especially your students who are going to struggle and who have learning problems or behavior problems. Math is going to be difficult for them. So you have to make sure that you have the knowledge, you are being explicit, you're being concise, you're being clear, stuff like that. You want to think about using small groups when you can with focused instruction and activities. And you also want to provide immediate and specific feedback and correction. You don't want a student to learn something incorrectly and then do 10 problems and realize they've done them all incorrectly. You want to, really monitor their progress and identify their errors in their math thinking. Okay, some other considerations you might want to think about: alternative approaches, matching the textbook and resources to student needs, real life applications, right, as much as you can, thinking about how you're going to teach the students to generalize or transfer those skills to new situations, and then help students set goals and maintain their own progress charts, because of course you're going to monitor their progress in math. All right, so some instructional approaches. We want them to be proficient, right? We want them to be proficient math people. So the National Research Council identifies 5 strands that compose math proficiency. So this is conceptual understanding, understanding the concept behind a skill or an operation. Procedural fluency, ability to conduct math operations and practices accurately and efficiently. So we want them to be correct and efficient. Strategic, we want students to be able to formulate and conduct math problems. Adaptive reasoning, thinking about explaining and justifying math work. Maybe they solved a problem a different way than another student, but can they tell you how they did it? Can they explain it? Because there's not necessarily one right way to solve every math problem, right? So you want your students to think about multiple ways, but you want them to be able to use their words to explain how they solved something. Okay, and then we also want students to appreciate math and understand that math is important and math is, contrary to popular belief, beneficial. So some instructional practices for math you can see apply 11-2, using data, of course, about instruction and progress. So that comes back to monitor their progress and adjusting instruction to meet their needs, involve parents in their child's learning, design effective instruction that meets their needs, and thinking about using computer assisted instruction for computation, problem solving, stuff like that. I am going to go fairly quickly from the slides from the textbook because, like I said, I added in a bunch of extra slides and I want to make sure I have time for those. Students who are culturally and linguistically diverse, CLD, remember, pair those students up with other students who have similar backgrounds. Use manipulatives. We want to start as concretely as possible. Model positive attitude. Infuse aspects of your students' cultures into math lessons, right? That will help to make it more relevant to them and more real world. Use technology. All right, so thinking about assessing and progress monitoring mathematics performance. So you want to think about, early on, starting with things like number sense. So that's just something like number identification, right? Can you give them a sheet of numerals and they identify them? Can they count by twos or tens? Can they oral count? Just start at one and just count. Stuff like that. Can they look at, and I'm not sure what slide this is on, quantity discrimination, which number is larger? Okay, so you can think about RTI, remember that, response to intervention, or MTS squared, for excuse me, grades K through 5, think about whole numbers and then irrational numbers starting grades 4 through 8, visual representation, fluid retrieval of facts, and of course, monitoring progress. So some pre-number skills, kind of those early numeracy skills, maybe you'll have, 3, 4, 5-year-olds. You want to think about one-to-one correspondence. Do they understand the relationship between number words and objects? You want to use objects for students to match with a designated number. Show me 7 teddy bears, 1, 2, 3, whatever. Give a number to match with corresponding number of objects, okay? Classifying, so all of these things. I ask students to group different colored, shaped, sized objects, however, put all the triangles over here, put all the squares over here. Oh, put all the red shapes over here, put all the blue shapes over here, right? That is classifying and sorting. Seriation, you want to teach your students to order objects by length, height, color, weight, stuff like that. They can stack their books from largest to smallest, pencils from shortest to longest. You could have them get an order of who's the shortest to the tallest. You could look at number of names, number of letters in their names, and they could put themselves in order by that. There is algebraic principles, mathematic patterns, relationships, and functions. All right, so concepts in computation. This includes knowledge of numeration, place value, which is really this, one of these early math skills, but it's so essential to everything that comes later. This I did want to draw attention to. In the textbook, it provides 18 readiness concepts, including cardinality, okay, face value of 10 digits, and place value, which is the position of a digit. And there are 18 concepts. They provide excellent examples of in the textbook. So I want you to take some time and visit page 364. So it'll say like concept 1, cardinality, but it gives you examples of how you can assess these readiness skills, this early readiness skills. Concept 2, grouping patterns. Concept 5, 1 digit per place. So I did want to make sure to draw your attention to this, and I think again, it's really it really breaks some stuff down for you. It even tells you, how much is the 6 worth? Okay, what is the 4 worth? So it gives you some great concepts and great steps, that you can use to assess your students with these early numeration concepts. So again, that starts on page 364 in your textbook and it goes to page 368. So visit that when you get a chance. You want to teach place value, using those blocks, those place value blocks, and then thinking about 3-digit and 4 digits. You want numbers, you want to provide opportunities for students to group, orally name, and sequence place values. All right, addition, subtraction, multiplication, division. They really need to understand their basic facts, right? They need to be able to perform basic operations quickly and accurately and solve problems effectively and efficiently. For students who are struggling with basic facts, that's going to take over everything else. It's going to take so much time. It's going to take so much of their working memory. So we want to teach them strategies to be able to quickly and efficiently solve basic math facts. So you could teach thinking strategies like using doubles, counting on, which is one, you would start with, you have 7 plus 5, you would teach them to start at 7 and count on, okay, 8, 9, 10, 11, 12. The first strategy is really counting all, where they would start, they have a group of 7, a group of 5, they would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We want them to get to the point where they're just looking at the group of 7 and then they count on from that 7, 8, 9, 10, 11, 12. And then of course we want them to just know that 7 plus 5 equals 12. Okay, commutative property, 7 plus 5 equals 12 is the same as 5 plus 7 equals 12. One more or one less than a familiar fact, that's where doubles come in. 6 plus 6 is 12. Okay, so I know that, but if I have 6 plus 5, oh, well, I know that's one less than the doubles. I know that will equal 11. All of these things are mentioned in your textbook. You want to teach the relationships between addition and subtraction and multiplication and division. You want to use some tutoring, peer groups, stuff like that. Teach the language of math computation, again, math vocabulary, and allow calculators as needed to promote problem-solving skills. All right, time for a super quick joke. Ready? What do you call a ruler, a protractor, and a compass all hanging out together? Weapons of math instruction. I just thought it was funny because it leads into fractions. So then we have fractions. I'm going to show you something at the end that is so cool about fractions. So stick around and I guarantee you it will be in part 2. For fractions, you want to think about proceeding from concrete to abstract. Okay, so you want to give them manipulatives first, give them things they can move around that they can manipulate. Then go to the kind of semi-concrete, semi-representational. You'll see that in just a minute. And then go to abstract. Teach the language of learning fractions. Build on students' understanding of sharing. Show how fractions are numbers with all properties of numbers. Use area models, number lines, visual representations. So not just, the circle, right, and dividing into fraction. Thinking about number lines, you have 0 and you have 1. How can you divide that into fractions? You want to teach strategies for solving ratio, rate, proportion, and improve teachers' understanding and skill in teaching fractions. Because I guarantee you, some of you are sitting there thinking, ooh, I hope I don't ever have to teach fractions. Well, guess what? Even in kindergarten, it's fractions. Okay, so another important area of math is measurement. So that includes weight, distance, quantity, length, money, and time. Think about how abstract time is, right? Oh, in 5 minutes, we're going to blah, blah, blah. Well, what does that actually mean? Time is abstract and it's hard for students to understand. So you want to teach them how to sequence events. What do you do first in your day? How identify the events that take longer. Okay, what takes longer? Brushing your teeth or taking a shower, something like that, right? Or doing your homework or saying hello to your friend. What takes longer? So money, also tricky, of course. You want to teach them to learn the value of different coins, identify bills, combining the value of bills and coins, which of course, why would we not make our students do that? So I feel bad for these kids. I really do. Math is hard. There's also problem solving, which is something we want to think about. This, of course, is going to be a difficult aspect for your students who are struggling. So you want to think about teaching them big ideas, keywords. Again, we talked about that, keywords, stuff like that, reasoning. Simplify your syntax and story problems. Don't include extra information. They don't need it right now. They're struggling enough with learning problems and or behavior problems. Just give them what they need, right? They don't need all the extra information. You want to limit the content load, keep the content suitable, interesting, fun, relevant, monitor their progress, of course. I think I've said that in almost every chapter for this textbook. And thinking about computer-assisted instruction as well. All right, so there's a couple methods of teaching story problem solving. So these are some recommendations from IES, Institute for Education Sciences. Prepare problems and use them in whole class instruction. So do that with everybody, right? Help students monitor, reflect on the problem solving process, teach them how to use visual representations, expose students to multiple problem solving strategies, which I'm going to show you some in part 2, and then help students recognize and articulate mathematical concepts and notation. So just some steps for teaching students to solve problems. You can teach them something like this. Read the problem, explain unfamiliar words, find keywords. Reread the problem, identify what is given, what is asked for. Illustrate the problem with objects or pictures or tally marks or whatever. Decide what operation to use. Write the problem and then work the problem. And there's one strategy called run. Read the problem, underline the question, name the problem type. And then you want to teach them how to recognize different types of problems. All right, I'm going to stop there because I'm almost out of time, but come back for part 2 because I have a ton of strategies for you in part 2.